Hey everybody, welcome to tutorial 2, where we're going to continue our introduction to Macs and begin to look at how computers become interesting partners in art making when they offer us something unexpected. In the first tutorial, we really were focusing on getting expected results, and now we're going to move into the space of helping the computer to surprise us. And this is the heart of interactivity. We don't just want a reactive system, we want an interactive system. And an interactive system is going to give us a novel response to some sort of input. And a deeper and deeper exploration of this is going to be much of the work of this class. So to begin with, let's go back to your tutorial 1 project. And let's look at it again for a moment, because there's one thing in here where you can already get some really interesting unpredictability without any additional objects or concepts. We'll go into the sound portion, and we'll look at this just in sound for now. And this is the principle of asynchronous looping, which is simply that when two loops are the same length, they will come around together each time. Then we'll see the same two images juxtaposed against each other every time the loop repeats, or we'll hear the same two sounds mixing every time the loop repeats. But as soon as the loops become of different lengths, they're going to change their relationship each time they come around. I'm going to do these two loops, and you'll see that they start in sync, but because they're different lengths, after the first iteration, they're going to drift out of sync. And so the note relationships between the two musical phrases are going to shift as they drift further and further out of sync with each other. So listen to that. So you can hear each time it comes around, it's reinterpreting the phrases because the relationship between the two is different. So it's a way of creating variation and interest just with the very, very simple tool of asynchronous looping. And a similar principle is created when we change the speed of one of our loops. So notice I've created an attribute here, and I've chosen the speed attribute. And simply by making a tiny difference in the speed of these two samples. I'm going to just play the sample for you right now by itself. This is a straightforward drum loop, but listen to what happens when one of them is 0.5% slower. It's 99.5% of normal speed, where 1 is normal speed. 0.995 speed. I'll start them together, and they will immediately begin to drift apart. And the initial sound you're going to hear of them drifting apart, we don't perceive it as a rhythmic delay yet because the difference is so tiny. We're going to perceive it as a change in the tone color. And then it will become a rhythmic delay, and they'll keep shifting further and further out of phase with each other. So let's listen to that. And if they get into kind of an interesting rhythm, simply by changing the speed of the right loop back to 1, they're going to maintain that relationship because now they're being played at the same speed, so they're no longer drifting apart. And as soon as I change the speed again, they'll begin to drift again. And of course we can do something more dramatic. For instance, play the right loop at 2/3 of the speed of the left loop. There's just the slow loop. I've faded out the fast loop. I can bring it back in. Just layering it with a copy of itself being played at a different speed gets some really unpredictable and continuously changing interactions between the two layers of sound. So that's just two things that are possible with very, very minor modification to what you did in tutorial 1. Let's go a bit further in our new tutorial. And again, I'm going to begin just with sound. The principles apply equally to image. And also I'm going to show some applications in image during the tutorial because there are a few different concepts necessary when working with image. So to begin with, I'm just going to bring in some sounds. These 6 sounds to start with, and create an easy DAC to hear them. So we're going to take a look at the 4th outlet of playlist tilde, which is playback notifications. And if I connect this to the print object, this will cause the playback notifications to appear in this window, which is the Max console. And print will actually take an argument which will label the information that appears here. So let's just send a message just so you can see what this looks like. If I send hello there to the print object, it prints playback notifications, hello there. Well, that's not actually a playback notification, just a test. I can clear my window with the X. And now when I play a sound, watch what prints in the Max window. It prints start 1 and then the file name, and then done 1 and the file name. It prints the start message when the sound starts, and it prints the done message when the sound is done. Let's look at another sound. Start 2 and done 2. There's a lot of silence at the end of that sound. The object is telling us when a sound starts and when a sound ends, and it's giving it to us in a format that actually we're already familiar with. It's giving it to us in a 3-element list. We looked at lists in tutorial 1, and that's what the pack object does. The pack object combines elements into lists. And here we have a pre-made list that begins with a word, either start or done. In the second position in the list, there's an integer referring to which sound. And in the third element of the list, there's a symbol, which is the file name that's being played. We can also look at this in our patcher by utilizing the right inlet of the message box. Take a message box, and rather than connecting the left inlet as we typically do, we're going to connect the right inlet, and that turns the message box into a display object. Right, we're seeing the messages as they come in. They're replacing the previous message. And one of the objects we can use to look at the contents of lists is called route. And route searches the first word of a list. So if we say route done, it's looking for lists that begin with the word done. So now if we connect our message box to the output of route done, nothing happens when we start the sound, but when the sound is done, it has stripped off the word done and given us the rest of the list. So route looks for a word at the beginning of a list, and if it sees that word at the beginning of a list, it removes the word and sends out the rest of the list. So when I start sound 5, we won't see anything because this route is not looking for the word start. But when the sound finishes, because it is looking for the word done, it will strip the word done and give us 5 garage volley 5.wave. And there it goes. And we don't actually need to use the contents of this notification. We can convert it into a button press just by connecting a button to the output of the route. So instead of interpreting this list in any way, we're simply turning it into a button press, which we can use to play the next sound. And what I'm about to do here is actually an extremely powerful tool for creating complexity. I'm going to create a feedback loop. I'm going to take this button press and feed it back into the next message. So this loop will be eternal. Every time a sound finishes, it starts the next sound. I'm going to remove this message for the moment just to make this path a little clearer. Lock my patch, and let's see how it goes. All right, but I have to turn off my sound to stop it. There's a simple object that we can insert into this feedback loop called the ggate, which will allow us to turn it off. So typically what we'd do is connect this to the right inlet and the right outlet, and that would be our on state. So the button press will flow through the gate, trigger the next message, which will cause the next sound file to play. And if we click this, now you can see that this button press is going to come into the gate and fall out of the left, which is not connected to anything. And we can control this with messages, as you might expect. 1 is on, and 0 is off. On, off. We can also click it. What we don't want to do in this particular case is use a toggle, and here's why. If we connect a toggle to this, and we turn it on with a toggle, and then we turn it off by hand, note that the toggle doesn't turn off because information flows from top to bottom in Macs. No information is flowing backwards up this cable to tell this toggle, hey, no, we've actually turned this off. So a toggle can give you incorrect information. A button, however, will cause a gate to flip-flop on, off every time it receives a button press. So messages and button presses are valid ways to interact with this gate. And when I want to turn it off, I can just click that gate and it will stop flowing through. So that's interesting. That's useful. What if I didn't want to use the next and I wanted some unpredictability in the order of sounds that are being played? That can be achieved with the random object. Because we have 6 tracks here, I want to create 6 random values. Random responds to a button press, and we can use an integer number box here to see what the random is putting out. So every time I click the button, I'm going to get one of 6 random values, including the possibility that I'll get the same value. So the one problem with this is the 6 random values I'm getting are 0, 1, 2, 3, 4, and 5. And we don't have a sound number 0. Our first sound is sound number 1. And also note, slightly confusing here, these sound files, this goes 1, 2, 3, 4, 7, 8. That's because I just dropped sounds 7 and 8 in over sounds 5 and 6. These numbers do not relate to the track number of the playlist tilde. They just happen to be in the file name. So how do I solve this problem of my range of numbers here is 0 based, but my tracks are 1 based? Well, this is an incredibly common thing you're going to run across in computing. This is not a Max thing. This is in all computing. You have 0 based lists and you have 1 based lists, and you just need to convert between them. And the simple solution is to just add 1 to whatever this random generator puts out. And in fact, I'm going to move this number box. If you ever want to move an object that's already in line, you can hold down the Shift key and it'll pop right out and seal the connection behind. And I created this with the N key for new object box. And I just typed in plus space 1. So now my random numbers are between 1 and 6 rather than between 0 and 5. And this will play the sounds randomly. If I want to create the situation where whenever a sound finishes, a new random sound is played, I'll simply remove my next and insert the random structure into my feedback loop. Open this gate and start the process. There's an object very similar to random called earn, which will give me these 6 values in a random order one time without repetition. So if I just replace my random with my earn, I'm going to get each sound once in a random order. 3, 6, 1, 4, 5, 2, and then it's done. And if I want to reset it, I send it the clear message, and now it's going to give me the 6 sounds again in a different random order. And one of the nice things is, when it's done, it sends a bang, it sends a button press out its right outlet. So if we hook up a button to the right outlet of the earn, we'll clear the earn again, get our 6 sounds. And on the 7th press, it reports, oh, no, I'm done. And we can use that 7th press to clear it. And this is another example of a feedback loop. When the earn is done, it clears itself. problem with this is when it clears itself, it does not send a new sound. So if we try this in our feedback loop, clear it, it's cleared, it's ready to go again, but it has stopped the process. So we can solve that problem in a couple of different ways. One way to solve it that will also show you a new feature of message boxes is to send two messages from a message box in sequence. We've seen sending messages as a list, right? These two twos will be sent simultaneously as a list, and we saw that in the last tutorial when we were trying to scale imagery proportionally. But if we put a comma space, they will be sent sequentially. So first it will clear the urn, and then it will send the message bang. And you're saying, what's bang? Well, bang is what I've been referring to as a button press. When we press a button, it actually sends the word bang. So now we're back in the eternal loop, because when the urn is finished generating its 6 random numbers, it sends a bang, it sends a button press to this message. This message sends the message clear, followed by a button press, followed by a bang. So it clears itself and is re-triggered. So that puts us back in an eternal feedback loop situation. So these are two very simple, very useful objects for creating unpredictability, for creating randomness. Let's take a look at a few more things. One thing I want to note is that so far we've been loading a different sound into each track of the playlist tilde. And that's not necessary. We can actually take the same sound and put it in every track. And why would we want to do that? So that we could play different segments of the same sound file. If you're working with text, this is very useful. You can record a bunch of words, for instance, or a bunch of phrases into a long audio file. First, I'll just play you the whole sound file. Okay, that's what's there. I can select different sections of it. They can be of different lengths. And this is going to choose them, because I'm using the urn, we're going to hear them in a random order, and then when they're done, we'll hear them again in a random order. And if I change this urn to a random, I'll leave the urn over here. Now there's going to be the possibility of repetition. And random does not understand the clear message, nor does it have a write outlet. So I'll put this over here with the urn. I'll take some images and bring them into the patch. These are arbitrary images. I'll make a jit.world at floating 1. Toggle to turn it on. a jit.gl.layer, and I'll connect my images to that. And here's a trick. You can hold down Shift to connect multiple things to the same inlet or outlet. And ordinarily, I would put a button on each of these images so that I can send the image to the layer. But I don't actually need to do that because I'm going to use an object that creates button presses called select. And what select does, very similar to route, it looks for an incoming message. And when it sees that incoming message, it sends a bang, it sends a button press to the corresponding output. So since I have 6 images and I'm generating 6 numbers, I can say select space 1, space 2, space 3, space 4, space 5, space 6. And watch, when I click away from it, I get 7 outlets. I get an outlet for 1, I get an outlet for 2, etc. 4, 5, 6, and this is messy. I can shrink these down so that I get a much nicer arrangement there. I can Command Y that to get them all line up. So when an integer of 1 passes into the select, a button press will happen on the first outlet, 1, and that changes to image 1. When a 2 comes into the select, the second outlet will send a button press. And you see when you hover, it actually tells you, bang if input matches 2. So if the input matches 2, it sends a bang and chooses that image. So I can hook this right up to the random numbers coming out of my random, and it will switch images along with the changing sounds. So in order to do something similar with a movie file, we unfortunately can't use the jit.playlist object that we saw in tutorial 1. We need to use a different object, but there's an easy way to have Max create that object for us. Here's my movie file, my video file. If I option drag it into my patch, note I get several options here, and one of them is create a jit.movie object that loads this file. That's what I want to do. And it creates the jit.movie object at movie file and then the name of my movie. And so we put this on a layer, move that layer in front, we see that my movie file is now playing. And jit.movie is just a video player object that has a lot more options than the playlist does, but it deals with only one video file at a time. So I can stop the movie playback with a stop message, and then I can jump to a specific frame, say frame 100. And that will jump the movie to frame 100. So this is the equivalent of what we were doing here with the still images. We can use the same select object and have different frames to go to. Frame 100, frame 200, frame 300. I'm picking these arbitrarily. Frame 400, 500. And you might say this is rather inefficient and messy, and it is. There's much more streamlined ways to do what I'm doing here which I will show you one in a moment. So now I can jump around to different frames in the movie. One attribute of most objects that's quite useful is the enable attribute, which just allows you to turn things off. So I can turn off that image in the background. You can also send that as a message, enable 0. So here I'm jumping around within the movie file every time a new random sound is chosen. And the movie can be stopped, or the movie can be playing. But in the case of this movie, it's very hard to see that unless the movie is stopped. So just to clean up a mess like this, there's a very, very useful object that you'll end up using all the time called coll. And it's just a collection of data. And the coll object will take some input, like the number, and send some output, like the frame message that we want. And the one thing that you need to be careful of with a coll is that it saves its data with the patcher. You need to go to the inspector and choose Save Data with Patcher so that the coll will retain its information. And inside a coll, there's just a text file. You double-click it, it opens up an editor. And you do input, comma, output, semicolon. And we want the message frame 100 to come out. And when a 2 goes in, we want the message frame 200 to come out. 3 goes in, frame 300. 4 goes in, frame 700, whatever it is that you want. Put in 2 more values here. Close it, validate it, and now that is saved in here, and you can hook up a message box, the right outlet of a message box, if you want to see what that coll is sending. And of course, you can add a second layer of sound as well. So what I'm going to do here is I'm going to select some longer looping sections. And I'll bring in another set of sounds. And use a different random generator to pick between these 5 sounds. Probably what you want to do here is differentiate your image section from your sound section. So I'll just put all the sound together here and put all the image over here. And of course we can Command-Shift-E to encapsulate as well once the screen starts getting very messy. Using segmented patch cords, I'm going to need my +1 there, and we'll see how this works. Quite nice. Another extremely useful object is the delay object. So if we want something to happen a fixed amount of time after something else, we can delay a button press. And delay only works on button presses. There's different objects to delay different things. So you could say delay 250 milliseconds as a quarter second, and I can simply generate a second random sound a quarter second after the first one. By inserting a button, I'll hold down Shift to insert. And now 2 random values are going to be sent to this playlist a quarter second apart. I can add another one. And the thing that's a little not optimal about this is that these sounds are being cut off. So I can actually just make 3 separate copies of the same playlist tilde. And connect them all up to my sound output and give them each their own random. And now the sounds won't interrupt each other because each of them can play its full length. Okay, not bad. That's getting kind of interesting, and the images are also still changing here. And we could see both images change if we turn on the other one because this select is still in play. And 2 final things I want to quickly show. Anytime an object has 2 inlets, the right inlet will typically enable you to change this value. So right now this value is set at 250 milliseconds, a quarter second, and this one's set at 500 milliseconds. I could, for instance, have the delay randomly selected anywhere from 0 to 2 seconds each time the sound is played. Now note things are starting to get messy here. We have image happening over here. We have sort of density in sound. So this might be a good moment to think about encapsulation. Command-Shift-E. And now I've got my entire video system nicely encapsulated here. I left my jit.world outside, and I left my start and stop buttons outside. tidy this up and just stick it out of the way. And we'll see what this randomized delay sounds like. Integer number boxes to monitor the times of the random delays. The other thing that's really useful with the random object is a likelihood of something happening. A percent chance of something happening. So if we say random 100, that gives us a random value between 0 and 99. And if we say we want to know if that random value is less than, space, 20, there's a 20% chance that this random value will be less than 20. There's an 80% chance that it'll be greater than 20. And as you might expect, the less than object outputs a 1 if the condition is true and a 0 if the condition is false. So I can hook up a toggle to this and watch it happen. 20% of the time this will be true, and 80% of the time it'll be false. There it was true. There's true again. You can also use an integer number box if you want to watch this happen. 20% of the time it'll be a 1. You can also use the object we've already seen, which is select, which will look for 1s and 0s and send a button press when it sees them. So there's a 20% chance that the left button will be pressed and an 80% chance that the right button will be pressed. Why is that again? Because select is looking for 1 and 0. If it sees 1, it bangs the left outlet. If it sees 0, it bangs the middle outlet. 80% chance of outlet 2, 20% chance of outlet 1. And of course, you change this value to whatever you want. If you want them equally likely, now it's a 50-50 chance. It's a coin toss. So maybe these delayed symbols only happen a certain percentage of the time. We can take this structure right here and insert it before the delay. So now we'll always hear the first symbol. There's a 50% chance we'll hear the second symbol, and perhaps a 20% chance that we'll hear the third symbol. And I will remove these delay time randomizers for the moment so it's a little bit easier to hear what's going on. Sometimes we're hearing one symbol, often we're hearing two symbols, and occasionally we're either hearing the first and the third symbol or hearing all three symbols. And these are the tools to begin to play with building complex structures.